Hello, my name is Mr. Wilke, and I'm here today to teach you about the chi-square test for association independence. So if you watched the last video, that was chi-square test for homogeneity of populations. With homogeneity of populations, we had several different populations. We were seeing, are they all the same? H naught, they're all the same, or HA is at least one different. With the chi-square test for association independence, it's really similar. The difference is we draw a single simple random sample from one population. So instead of testing to see are several populations the same, we're taking one single population and so draw a single SRS from one population and sort them according to two categorical variables. So if you remember earlier in the course, we talked about, can we find a correlation between categorical variables? No, because there's no number, but we put everything in two-way tables. We looked to see if there was a relationship. Here, we're going to be able to do inference on that relationship. All right, so draw a single SRS from one population, sort them according to two categorical variables. Now, inference is done the same way as the chi-square test for homogeneity of populations. Okay, so now when we did chi-square for homogeneity of populations, H naught was P1 equals P2 equals P3 equals P4 equals however many populations there are. All the populations are the same. HA was at least one is different. So H naught this time, H naught is going to be, there is no association, and HA is going to be what? That's right, there is some sort of relationship, there is an association. So what does this mean? Well, if our chi-square is large, the sum of all of our observed minus expected squared over expected, if that's large, what that means is, well, they vary, right? They vary far enough apart from what the expected is that the chi-square statistic is large. It's going to give us a small p-value, meaning we would reject H naught, the fact that there's no association. This is how we're going to show that there is an association between the two categorical variables. Does that make sense? Okay, so let's try a practice problem, and once again, do the magic of editing. This will become a practice problem. Ready, and go. And look, we have our problem. All right, well, we at least have some data. So here's what the data says. This says socioeconomic status. This says smoking. So what we're looking for is there an association between your smoking status and your socioeconomic status? So are you more likely to smoke if you're rich? Less likely to smoke if you're rich? Who knows? We're going to find out. So first of all, this data comes from a study from 1977, which explains why there's way more people who smoked than hadn't. It was the 70s. I was only 4 in 1977. I wasn't a smoker at the time. Or now. Anyway, let's look at the data. All right, well, what do we see? Way less middle. Interesting. Once again, 1977. Different world. All right. I don't know. Let's find out. What do we need to know? First, what's H naught going to be? That's right. H naught is going to be, there is no association. HA, there is an association. What am I missing? It's not in context of the problem. So when you write it out, when we formalize four-step inference, we'll put it in context of the problem. All right, so step one, we want to know, is there an association between smoking status and socioeconomic status? H naught, there's no association. HA, there is an association. Step two, conditions. What are our conditions? Well, this is real data, real study, real random sample of people, which tells us, yes, it's random. All right, are all expected counts at least one? Definitely. Are all, or no more than 20%, less than 5? This is the only one that's low, and that's the observed, not the expected. The expected would be what? 99 times 52 over 356. It's probably going to be more than 5. They're all greater than 5. We're good. Okay, we proceed with what? That's right, a chi-square test for association independence. Not homogeny of populations, association independence. Step 3, do the math. So, chi-square equals the sum of the observed minus the expected squared over expected. So I'll just start out with the first one. 51 minus something squared over something plus, we do the last one, which would be 22 minus whatever. We'll figure them all out. Let's do it on our calculator. So you'll notice on the calculator I've got the matrix in there. All right, so we're going to hit stat, go over to tests. Now, remember I said inference was done the same way. We're going to do the same test. The chi-square test on the calculator, there's one for goodness of fit test, and there's one for homogeny of populations. The association independence is the same one as the homogeny of populations. Observed in A, it puts the expected in B. Calculate, there it is. Chi-square equals 18.5097, so we'll call that chi-square equals, and I lost it. Chi-square equals, and I hit the wrong one. This is fun, huh? All right. We'll edit that out in post if we only had an editor. Chi-square test, there we go. Calculate 18 point, we'll call it 51. P-value equals, what's that? 9.8, that's huge. Oh wait, 9.8 times 10 to the negative fourth. So 9.8 times 10 to the negative fourth, that's pretty small, isn't it? Yes, it is. Don't forget, degrees of freedom. Why 4 degrees of freedom? Well, 1, 2, 3 rows, 3 columns. 3 minus 1 times 3 minus 1 is 2 times 2, or 4 degrees of freedom. All right, and can we get the, let's get the expected matrix. That way we can fill in, this is minus 68.75 over 68.75. when I'm showing my work, I always do the first one plus dot 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 plus the last one. So it'd be 22 minus whatever that is way over here. So 22 minus 25.862 squared over 25.862. All right, now step 4. Since our p-value is low, what are we going to do? Since our p-value is low, we reject h naught. So since p-value is low, we reject the h naught in favor of HA. Put it in context, there is good evidence to show that there's an association between socioeconomic status and whether or not somebody's a smoker. And that's it. Now, if you want, we can do 4-step inference, or you can try it on your own. For now, let's just try it on our own and see how you do. If you have any questions, put it in the comments. Put it in the comments for my class that's doing it this year. Put it in the comments on the Canvas when I post it. And yeah, that's it. We're done with chapter 13. That was it. I'll give you guys a practice test. I'll give you guys a review. We'll be ready to go. I hope that helps. All right, thanks a lot. Good night, everyone.